Demarcating L2 science from L2 research, science is not engineering, art, or decision-making, nor is it statistics.
Science is not the only human endeavor with a demarcation problem. In discussing the ontology of engineering, Mitchum 2020 begins with,
"What is science is a key question for philosophy of science. What is religion is a key issue in philosophy of religion. Such questions are sometimes called demarcation problems."
p11. As we can see, the rationale for demarcation is usually framed in terms of what science and pseudoscience or politics or religion are. But as we have seen, the demarcation that Collins and Evans 2007 propose is not justified on the basis of what technical expertise is, or on what democracy is. These authors seem to be more concerned with the purpose that a demarcation between them serves. In the case they present, the purpose is to 13. Protect democracy from technocracy, and to simultaneously protect expertise from political influences. My aim in this section is to offer several purpose-based demarcations, which may allow us to clarify the terms and conditions of consensus building, that is, what should we agree on? And, what is the purpose of the agreement? Following up with the previously established demarcations between fundamentals and facts, science and politics, science and decision-making, acquisition and education, as well as the phenomenon of L2 and its intervention, it seems to me that a very natural question is this: since research is conducted in all of these areas, should we not then demarcate science from research? To do so, we may need to first gain clarity as to the strange prestige science carries. Descriptors such as not science or not scientific are at times interpreted, and admittedly sometimes meant, as an insult. I strongly argue this should not be an insult. Instead, we could recognize that different human activities are designed to achieve different goals, and they all deserve respect and even protection as established by different criteria. In science, we want to find out what is plausibly true. We want to explain phenomena. Engineers try to manipulate and control such phenomena, based on those plausible truths. See Mitchum 2020. Artists and philosophers contemplate on humans' ideas, emotions and values, through truly free thought, without restricting criteria, and without limiting epistemic constraints, and they innovate on our symbolic realities through creativity and self-expression. Decision-makers engage in a tough human endeavor, where they reflect, plan, organize, create rules and take action for the benefit, or to the unfortunate detriment of other people. In short, taking offense when confronted with labels like, not scientific, entails a certain confusion, as to the truly limited scope of science. In SLA, scientific research would try to observe what is plausibly true about L2 acquisition. Where does it come from? When did it start? How does it work? And so forth. Interest over what is effective, or over the best way to learn a language, I submit, does not belong here. It belongs to the realm of engineering, where the central goal is to manipulate phenomena at will, and, as mentioned in the previous section, yet another endeavor is to find ways to ensure better educational outcomes, which belongs to the realm of decision-making, where what is plausibly true, what is effective or ineffective, and what is best according to the means and values of educational communities, has to be all pondered and negotiated in order to arrive at decisions over courses of action. Nuance is of great importance in this discussion. Although these four activities, science, engineering, art and decision-making, differ as to their essential goal, the existence of border-like demarcations does not cancel the possibility of mutual influence, interaction, borrowing, overlap and/or coordination. For example, science may provide descriptions of truth that engineers will use, and through this use perhaps they will accidentally test them. Failure to conform to truth descriptions then creates a puzzle which science has to solve. Engineering is not only the application of science, it generates its own kind of practical knowledge about effectiveness, and it requires humanistic qualities such as purposeful design and creativity. Engineering also establishes notions of what is operable, or can be operationalized, which decision-makers may take into consideration to establish appropriate policies. Policies are filtered through humanistic lenses such as moral philosophy, democratic values, legal theory, etc. Policies are then built and implemented. In time, policies have outcomes, which may be unexpected ones, a situation that needs to be explained. These can be seen as natural experiments, which brings back scientists into the picture. Due to these 14 inextricable relationships, we may start seeing these four realms as a single one. But relationships and unity are two different things. My argument is that SLA research is characterized by the conflation of these four realms, for historical reasons. We could say SLA researchers started from natural experiments, albeit the ones they had access to, the ones in the classroom context. Then they created scientific explanations to account for what was perceived as non-desirable outcomes, taking the role of scientists. Then they tried to come up with solutions through pedagogies, thus carrying out the task of engineers. Researchers in SLA, as it is often pointed out, often come from the realm of L2 teaching, where their role was that of decision-makers inside the classroom. Pedagogical interventions then have been devised, applied in classrooms, and in scientific fashion, published in academic journals often supported by the scientific-sounding use of statistics, thus giving rise to a field where carrying out all possible roles indiscriminately is the norm. I have purposefully brought engineering to this discussion as I found it allows us to establish a difference between naive, bottom of things, curious explanation, and problem-solving, self-serving, goal-orientated intervention. Arriving at explanations does nothing to solve social problems. Intervention is needed, so obviously we need and want both, but these are not the same thing, and through the lens of this demarcation, one could argue that a focus on pedagogy and outcomes stresses the engineering part, more than the science part, not to mention L2 pedagogy is by no means the only L2-related social problem to be solved. When L2 acquisition is the naturally occurring phenomenon, and pedagogy its artificial intervention, one can see that the focus in those kinds of studies is on the pragmatic manipulation of phenomena. It is outcome-based, in a context where practice is equal to teaching, a context in which ultimate explanations of language and acquisition development are not but tools to reach such outcomes. Perhaps one very clear example of this is Polio 2012. In this paper entitled The Relevance of Second Language Acquisition Theory to the Written Error Correction Debate, the author seems to do two contradictory things. On the one hand, she defends the value of theories to gain clarity as to what now is a classic SLA debate. Each theory, with a different research program, has revealed different insights into the issue, as she portrays it. No one would argue with that, but what I think is not really a defense of the relevance of theories is the next step, where the author presents the general key findings of each research program, as a sort of unified list of pieces of knowledge that can be useful for teaching. In doing so, the author seems to think theories have no real function as mutually exclusive lenses to interpret truth, or that the clashing of theories is purely philosophical and inconsequential. Although my tone may be critical here, I have to admit that in my facet as an L2 teacher-learner, I often engage in these kinds of thoughts, at least in some cases and from a practical perspective. When I'm teaching or learning languages, sometimes I have to put explanation aside, especially in the context of no consensus, and focus on the tools and techniques that are available to me and that seem useful and helpful. In our outcome-based teaching jobs, one cannot really get too dogmatic, even when we try, much less in a context where we are not allowed to innovate, or where innovation creates financial challenges for an educational institution. There are simply too many factors to take into consideration as a teacher. But if we, on the other hand, examine the issue from the perspective of a scientist, who is concerned with explanations, then we simply cannot run away from the realization that mixing many theoretically different research programs to obtain theory-free practical insights is a little bit like mixing apples, oranges, and kiwis to obtain tomato juice. Even though in pedagogical practice we may find ourselves using all the fruits, I insist that in science facts are not theory, neutral, and that there is a fundamental difference between controversies over the fundamentals and controversies over particular facts, which means research programs will be partially, if not completely incompatible depending on particular issues. This fundamental differences between science and pedagogy are the reason why we need demarcations. Theories of fundamentals matter, and from an explanatory perspective, whether corrective feedback works, is a proxy debate to that of whether declarative knowledge can be proceduralized, and from a deeper, more ontological perspective, the issue is also dependent on whether, regardless of proceduralization, we decide to believe declarative linguistic knowledge can be called language, or not. 15. Theories do not tell us practical teaching insights. They tell us whether debates over written error correction are the right debates to be had in the first place, or whether we should first take a step back and look at what mechanisms, either general or particular, would govern the effects of corrective feedback on writing proficiency. Observations which themselves are additionally dependent on how we choose to define and measure proficiency. In explanation, as Kuhn helped us elucidate, some things depend on other more fundamental things. The issue here is that as teachers, we want to know what to do. Decision-making is imminent. It cannot always depend on what is plausibly true, on what is scientific, as Rod Ellis reminds us through his invitation to engage with educational literature, see Chapter 5. Decision-making also cannot depend on whether a technology or method to ensure L2 acquisition exists or not. Being alive requires decision-making. Just like hospitals cannot be shut down until we find cures for all diseases, L2 classes cannot stop until we figure out how to go from fundamentals to facts to engineering, and only then to decision-making. We have our students in front of us, and for most of us, it just comes natural to want to help them achieve their linguistic dreams, at least the ones who are not forced to be there. Nonetheless, this desire for useful insights, along with observations of successful learning, often blind us as to the rigor needed in scientific practice to make certain claims. What is perceived as good practices or gold standards in the realm of decision-making, for instance proficiency tests, carries a confusing social prestige, where based on common practice we actually think proficiency tests measure proficiency, when in fact we know there is still no scientific basis to claim this, since science has not even figured out what L2 proficiency is. The practical utility of proficiency tests is so valued that actual researchers then incorporate them into studies, usually under the term L2 achievement. A variable that is ignorant of any and all legitimately scientific controversies in linguistics and SLA over how to even define, not to mention explain, describe and measure language and proficiency. The implication here then is that these studies may reflect something approaching practical truths, but not scientific ones. In other words, it may be that in rough terms, proficiency tests actually discriminate effectively between people who struggle to communicate and people who can use their L2 in very fluent, receptive and natural ways. It may even be the case that some interventions lead students to go from the former condition to the latter. But, to put it in the clearest of terms, it does not follow that because something works, then it is true. Science is not concerned with what is effective neither pedagogically nor statistically, but with which, out of multiple possible explanations, actually explains the phenomenon in question, and as an added bonus, what explains the effectiveness. Not only that, it is the theory that provides a definition of effective in the first place. A pedagogy-orientated researcher may in fact be content with not being labeled a scientist, who wastes their time in such intricate matters, when real problems require real solutions, or even when we sometimes assess that we already have acceptable solutions. After my interaction with Rod Ellis, see Chapter 5, and reflecting on my teaching experiences, I am less and less dismissive of these notions, at least where pedagogy is concerned. But adopting a more comprehensive perspective, I would have to argue that a common assumption in applied linguistics that a non-applied purely scientific field does not solve problems in the world, has to contend with all evidence to the contrary throughout the history of science and technology. Scientific knowledge of fundamentals has always informed and more generally been the backbone of solutions to all manner of problems in truly unexpected areas and in truly unexpected ways. But for that to happen, we need curious minds from around the world to inquire into deep aspects of SLA, which remain invisible to us, not to mention training that fosters theoretical curiosity, rather than research gaps that promote a superficial understanding of scientific progress, and basically serve the goals of publicationism. In short, while it is true that in practice science, engineering, art and decision-making interact, support each other and overlap, it does not seem advantageous to conceptually mix or conflate these endeavors, because this can easily undermine their individual strengths. Demarcation, consequently, should not be so concerned about what each of the four realms is, or where the precise borders are, but on the purposes they serve, or such is my proposal. In SLA, such rough borders could serve such functions as 1. Not undermining deep explanation only because it is not immediately apparent how it solves problems. 2. Not dispensing with effectiveness only because it cannot be explained. 3. Not paralyzing decision-making because a true science does not exist yet. And 4. Not devolving into a technocracy once the science is figured out. Table 3.2 Demarcations and their basis purposes. Rough demarcation. Purpose of demarcation. Science is not engineering. Explanation is not effectiveness. Not undermining deep science is not decision-making, explanation is not determination, not paralyzing decision-making because a true science does not exist yet, not devolving into a technocracy once the science is figured out. Purpose-based demarcations also have the benefit of being a flexible epistemological framework, where all research has something to offer, and we do not engage in dismissing certain types of research, or saying certain types of studies have no value, but instead that they have value for a specific realm, for example for science, but not for engineering, or for decision-making but not for science, and so forth. Academic freedom is key to creativity, innovation, discovery and theory testing. Not only that, but purpose-based demarcations can actually allow researchers to successfully coordinate more than one realm, while not violating any of the purposes. I will exemplify this with socio-cultural theory. In SCT we can find a Vygotskian epistemology in which there is an intentional coupling of theory and practice, where the idea is that
theory is only as good as the practice that supports it, and practice is only as good as the theory that guides it.
James Lantolf, Personal Communication, April 9, 2024. While I find that in SLA this approach may not meet the standard of intentional pluralism, as it does seem to see practice as synonymous with pedagogy, nonetheless the demarcations I present here do not all automatically run contrary to such an epistemology. Let us put it to the test. 1. Does this Vygotskian epistemology undermine explanations? No, explanation is one of its two goals. 2. Does it dispense with effectiveness, only because it cannot be explained? No, quite to the contrary, it says the explanation is not valid if practice does not support it. 3. Does it paralyze decision-making because a true science does not exist yet? Ideally no, because in this approach practice is a necessary condition for theory construction. The problem is that in this framework practice conflates decision-making with what I have been calling engineering, potentially obscuring or ignoring particular socio-political factors in particular contexts that mediate successful practice. 4. Does explanation devolve into a technocracy? No. In this approach explanation reigns practice and practice reigns explanation with equal force. As I mentioned above, there is a difference between relationships and unity, between coordination and conflation of the realms. SCT may try to coordinate explanation and practice, but it does not conflate them, at least not in an ideal version of these ideas. The purpose-based demarcations I propose above could further aid virtuous styles of coordination of the realms, but where all of them are protected rather than undermined. SLA research, though, routinely encompasses all four realms in a somewhat chaotic manner, sometimes in single studies. One of the possible reasons for this is the current epistemic prestige of inferential statistics in science. I am all for quantification. In Requena-Ramos 2024, I adopted the position that science needs numbers to be a science, but that often the history ontological basis and social consequences of the metrics and statistical procedures we employ are not part of our training, which leads to a risk of abusing numbers. We may have to also demarcate statistics from an L2 science, since statistics are used indiscriminately in all four realms, often lacking the explanatory lens of an L2 theory, and in ontologically questionable ways. We inherited this problem by relying so much on mainstream methods in psychology, a field that has been at the center of the replication crisis, among many other controversies. As Alexandrova and Hebron 2016 put it,
the theory avoidant status quo has developed in psychology owing to its operationalist heritage, which was key to its establishment as a hard science.
p. 107, an attempt to make studies more scientific via the use of numbers, creates an environment where researchers and graduate students may be under the wrong impression that all research containing statistics is automatically scientific, regardless of observations being left unexplained or heavily under-theorized, like studies where the variables are proficiency or L2 achievement. On this issue, Richardson 2021 writes,
"A fervent faith in method as the path to true knowledge shows up in mainstream social sciences' insistence upon the use of correlational and experimental methods, regardless of the subject matter being investigated. Unfortunately, it appears that mainstream social science, in spite of tremendous effort, remarkable methodological sophistication, and many decades of effort, has failed to achieve anything resembling the kind of explanatory theory often termed empirical theory that has been accomplished in abundance by the modern natural sciences, the kind of knowledge that counts as truth in these sciences and is needed for precise prediction and often instrumental control over events in their domains."
p. 113, emphasis added. I would like to highlight again that I do not believe there is something wrong with the methods themselves, but with their indiscriminate use in the context of theoretical voidness. In other words, there is nothing wrong with employing statistics, but we should keep in mind that statistical theories have built-in ontological assumptions, and that studies which do not engage with any of SLA's theoretical frameworks, which we could label theory-free studies, although potentially relevant to science, are not scientific studies in themselves. Why? Because it is not clear which theoretical lens to use when interpreting them, ergo it is not perfectly clear how they provide us with evidence. Richardson 2021 also addresses this problem in an insightful way.
Just describing interesting patterns of variables, which always have many exceptions, does not yield the sort of technical control over events we associate with modern physics, biology, or engineering. Correlational and experimental findings may illumine patterns and relationships among events in the social world or human experience. But the reason they do so cannot be that they reflect universally applicable causal laws or models of the sort regularly uncovered in the natural sciences. Well-developed theory to ground them is simply lacking.
p. 113 emphasis added. Remember, theories tell us what methods to use and what can be evidence. Truly scientific studies in SLA would need to either propose or adopt a theory of language or proficiency, for example a theory from formalist or functionalist linguistics, UG, UB constructions, BLC, HLC theory, etc., and a theory of acquisition, development that coherently corresponds it, for example DP model, IP, PT, MCF, UB approaches, SCT, CDST, etc., in order to interpret findings. By interpreting the findings in turn, scientific studies corroborate, complement, falsify, or more generally change the theories in some way. Whether a study accomplishes this or not is completely unrelated to whether it employed statistics or not. In a word, scientific studies try to help build, test, or restructure explanations, and consequently, limiting ourselves to empirically demonstrate what is effective, while lacking consensus in such areas, or altogether ignoring them, produces perhaps practical, but essentially pre-scientific truths. Practical truths can be useful, and valued by curriculum designers and teachers like myself, but they may be far away from being valid ethically and ontologically rigorous explanations. Philosophers of science remind us that human activities can simply take place successfully, before explanation is even possible or a priority, by using the historical case of airplanes, which could fly before we had a functioning theory of lift, Mitchum, 2020, Oreskes, 2019. This is an example of how pre-scientific engineering knowledge of effectiveness led to an explanatory scientific theory that allowed for both a deeper understanding of the aerodynamics of flying, as well as the possibility of further development in the design of airplanes. I would add that birds were flying even before planes, and presumably not because they figured out an accurate theory of lift either. Again, what works and what explains it are two different things, and birds flying when applied to SLA is the equivalent of our species' very old ability to learn additional languages and be multilingual. Practical truths present themselves to us as pretty straightforward, and they are difficult to ignore, but knowing something and being able to explain it are different layers of our understanding. Birds fly, but why? We can be multilingual, but why? Some planes are more aerodynamic, but why? Some pedagogical interventions have beneficial effects, but why? Explanation does not stop at why, though. It includes how, when not, why not that other way, why in this case but not that other case, why are there outliers? What is needed for this to happen? What is not needed? Why does everything crumble when we remove one condition? Why does everything not crumble, even when we remove what we believe to be a centrally contributing factor? Practical truths like beneficial effects in SLA may be useful for teaching, but they are neither explanations, nor based on the kind of social awareness that intentional pluralism would attempt to achieve by venturing outside of the realm of education and into the multiplicity of human L2 experiences. To synthesize, I would say that we are trying to explain a phenomenon that cannot be characterized as successful or unsuccessful, it simply is. But we narrativize it as unsuccessful due to a number of conceptual conflations, because we do not distinguish between success and native speakerism, between mysteries and problems, between phenomena and interventions, between all humans and instructed learners, between mechanisms and conditions, between lives and classrooms, between development and success, between understanding and controlling, between being able to control and being able to explain. So, not all research is carried out to the benefit of science, and this turns out to be a good thing. It may be healthy for all realms, however, if researchers adopt a more explicit stance. Either theories are the goal, or theories are not the goal. Both postures are perfectly valid and acceptable. Everyone should have the freedom to do whatever they consider important, and we should respect each other's goals. We can also coordinate the goals, as we have seen socioculturalists would even say we should, and indeed we probably should, provided we do not confuse or conflate them, and provided that in building a scientific consensus around L2 acquisition development, we will focus on basic science and intentional pluralism, where the goal is explanation, while in building a pedagogical consensus we will understand the fundamental skewness of a sample of instructed learners, and complement engineering with the socio-political intricacies that the realm of decision-making allows us to contemplate, and which also mediate effective learning, in a context where the goal is better educational outcomes. Summary of propositions in Chapter 7. In order to discern what a scientific consensus would entail in SLA, we need some kind of criterion of demarcation, one that goes beyond offensive notions of science versus pseudoscience. There is interference between the values of truth of the matter, and concrete problems and tasks. Arguments for how appropriate or inappropriate a research program is based on how much it can provide solutions for the classroom context problematically employ a philosophy of education to address issues that depend on a philosophy of science. Multilingualism as a socio-cognitive phenomenon predates most of the superficial conditions we find in classroom-based research. If the mission of the field is to get at better pedagogies, focusing on the intervention, rather than the phenomenon, then SLA and SLD are misnomers, while second language pedagogy seems more appropriate. Successful outliers whose experiences take place outside of instructed situations need to be explained, in a matter that depends on what is possible, rather than frequent or probable. For this reason I make the case for intentional pluralism. A common narrative is that L acquisition is difficult, and this is the problem to be solved, when in fact L2 acquisition has always happened, and the real problem is, we try to artificially force it onto all students under suboptimal conditions, largely because of socio-political influences along with unrealistic expectations. There is a need to re-examine scientific categories, as multilinguals cannot be neatly divided into L1, L2, child-adult, or naturalistic instructed. A big list of alternative categories is given. I point out these currently subordinate populations are indeed studied, but not taken seriously enough to reshape major theories in SLA, because of the pedagogy bias. I argue SLA research commonly conflates the realms of science, engineering, and decision-making, where goals from one activity interfere with the goals of another. I propose purpose-based demarcations that allow for an explicit understanding of the goals of each realm, as well as the opportunity to coordinate the realms in virtuous ways, with the condition that goals are not conflated. I argue the use of statistics does not immediately make research scientific, because the goals of many quantitative studies are not explanatory, or a theory is not adopted, where the findings can become explanatory. I further argue not all research is compatible with the main goal of science, that is, not all L2 research is L2 science, but that is a good thing. All realms are important and need protection. Through the lens of demarcation, my conclusion is that in building a scientific consensus we should focus on basic science and intentional pluralism, where the goal is explanation. While in building a pedagogical consensus we should first understand the skewness of such sample of learners, and complement the focus on the intervention engineering, with knowledge of the socio-political intricacies of decision-making, which mediate effective learning, where the goal is better educational outcomes.